All right, kids, welcome back. Never know whether to say good morning, good middle of the night, happy afternoon. So whatever time of day it is for you, I hope it is good. So today we're going to talk about slope of the secant line. And if you can find slope, then this is going to be a relatively easy lesson for you. So we were going to use the slope of the secant line to find the average rate of change of a function. So what is average rate of change? Well, average rate of change is simply the slope of the secant line. The secant line will pass through 2 points which lie on the function. So, for example, if we graph a parabola, and maybe we have some concave down parabola, and I pick any 2 points on my parabola, the line that goes through these 2 points, or not through these 2 points apparently in this case, will be your secant line. Now, the thing about secant lines, that's not the only secant line. I could come over here and I could pick 2 more points and I could draw another line. So essentially, a secant line is a point that, or a line that goes through 2 points on your function, as opposed to the tangent line, which might touch at 1 point on a function. And we will talk about the tangent line another day. So, secant line goes through 2 points, and the average rate of change is simply the slope of that secant line. So when we talk about finding the average rate of change on a graph, and our graph this time is the function f of x equals x squared minus 9. So I look at that and I'm thinking, wow, I have a concave up parabola. So if I were to do like a super quick sketch, it might look something like this. So what you have to remember on these, this value is x1 and this value is x2. And in order for me to find slope, I am going to need 2 coordinates. So I'm going to come in here, and when x is -1 and I sub -1 into the equation, you get -1 squared minus 9, which is -8. And when I sub 4 into the equation, we get 4 squared minus 9, 16 minus 9, which is 7. So you can think of this a couple ways. We can think, well, this is my x value and this is my y value. Some of you will literally do better if you come write these as ordered pairs. So this is kind of one of those points in life where you can write them as ordered pair. You could write f of -1 equals -8 and f of 4 equals 7. But regardless of the notation which the points are given, you should be able to come in and find slope. So when we find our rate of change, remember slope is our change in y over the change in x. So if I take my y value minus my y value over my x value minus my x value, oh, that should be -4 over -5, I get a slope of 3. So what does this actually look like on my graph? So I put this graph into Desmos so I could get like the perfect graph. And here's my concave up parabola. If you notice, your vertex down here is at 0, -9, so it coincides with the problem. This is the secant line. So if I look at this line, if I start down here at this point and I went, well, rise over run, I can see that from the x value of -1 to the y value of 4, the slope of that line, or that secant line for that function, is going to be +3. And that's essentially what we're going to be doing on this lesson. So this time they say, hey, let's write the equation of the secant line from -1 to 4. So on the previous slide, we found the slope. So this information is just from the previous slide. So my slope of my line was 3, and it goes through those 2 points. Remember, if we have an equation of a line, and we have a point, and we have a slope, we have to write it in point-slope form. So y minus y1 equals slope times x minus x1, and you should have that formula engraved in your brain. It does not matter which point I use, so I'm just going to use the first one. So you have, y plus 8 equals your slope times x plus 1. Technically, you can take this 8, move it over here, so y equals 3x plus 1 minus 8. And this is really an HK format, so, you know, if you think back to what we've talked about some last semester, this is a times x minus h plus k. And if you just want to write your equations in HK format, that's also a legitimate way to do that. I don't really need to solve because all it says is write the linear equation. This right here is a linear equation. I don't have to take it any further. Done. All right, so example number 2. So average rate of change, we're going to find the vertex and the x-intercepts and use them to graph the function. So we can do this a couple different ways. I'm going to just go ahead and factor. I think factoring is kind of fun. That was a joke. So this is going to be x plus 3 times x minus 2. So if I factor and I find the x-intercepts happen when y equals 0. So if I set this function equal to 0, and I know a lot of you skip these steps when you write them, but solid mathematicians would never skip all these steps, and it's kind of lazy. Plus, when you skip steps, you make mistakes. All right, so the average rate of change here, when I look at this function, I have x-intercepts at -3 and 2. I can find I can't remember if I have a graph that's going to pop up or if I need to draw one. Boo. Oh, there was one. Okay, so if I look, my x-intercepts are right here and right here at -3 and 2. If I want my vertex, you can do your vertex a couple different ways. X equals -b over 2a, which is -1 over 2 times 1. So the x-coordinate of my vertex is -1/2. I can substitute that back in any of these equations. For me, I'm going to substitute it in right here. So I get -1/2 plus 3 and -1/2 minus 2, which is going to give me, let's see, 5/2 times -5/2 times -5/2, which is going to give me a y value of -25 over 2. Why do I feel like that's wrong? Because this vertex definitely on this picture looks like it's not. It looks like it's about -6 point something. Oh, I know what I did wrong. 2 times 2 in my denominator is 4. So that's one thing. Check your graph with your math and make sure. 25 over 4 is approximately 6 1/4. So now that matches my graph. So now I have my x-intercepts and my vertex of that function. So remember, x-intercepts, factor, set the factors equal to 0. Your vertex, you could either average your x-intercepts or you could do the -b over 2a formula. So that's part A. So part B says, all right, we're going to find the slope of the secant line. So finding the slope of the secant line from -3 to 1. In order to find slope, you need 2 points. So right now, I have 2 x values. I have x1 and I have x2. So I need to find the corresponding y values. So f of -3, and I'm going to substitute that into my original function. So -3 squared minus 3 minus 6. So this becomes 9 minus 9, which is 0. So one of my points is going to be f of -3 equals 0. My other point is f of 1. Yay, 1's an easy number. So I substitute in 1 plus 1 minus 6, which is -4. So f of -3 was 0, and f of 1 was -4. And now I can use those two numbers to write my slope. So the slope of the secant line from -3 to 1 on the interval from -3 to 1 is going to be the change in y over the change in x. Y minus y over x minus x. Got some, oh, I don't know what my debacle is today. That 4 should be a 1. Nope. Okay, so now we have 4 over -4, which is -1. I can look at my graph, can start counting. If I start here, down 1 over 1, down 1 over 1. So that slope absolutely corresponds with the graph. So start making a point. Like, you have a visual aid in your graph to make sure that your algebra is correct or your math is correct. So always check them against each other to make sure that you are consistent and that everything is working correctly. All right. So I am going to give you a minute, so hit pause on example 3. I want you, oh no, let's talk about number 3. We'll hit pause on the next problem. Find the average rate of change of the function f of x equals negative 4x plus 1. If we think of negative 4x plus 1 and we're like, hey, I don't even get this. What am I supposed to do? Okay, well, 1, you could plug in negative 3 and 4. So I want you to take a minute. I want you to substitute in negative 3, substitute in 4, and then I want you to find the slope and then rejoin me. Okay, so average rate of change. So if we think about what this graph is, this graph actually, we have a y-intercept of 1, and we go down 4, so 1, 2, 3, 4 over 1, down 4 over 1, and we end up with a line that looks like this. So one thing we need to remember about a linear function is linear functions have a constant rate of change. So I don't care what 2 points on this line you pick, this equation is y equals mx plus b. So if you take the slope out of this, when you calculated your slope, you should have gotten negative 4. But if you would have put a little thought into what this graph looks like and what it means to be a line, and to be a line, you have to have a constant rate of change, the slope is going to be negative 4. So I don't really care what 2 points you pick on that line, your slope is going to be negative 4. All right, so part B says to find the equation of the line containing the point 2 f of 2 and the point 5 f of 5. This is just another fancy way right here of saying y. So we need to substitute in 2. You're going to get really good at this. But as you've seen me do, sometimes you can make silly mistakes. So f of 2 gives me negative 7, and then f of 5 gives me negative 19. And really, I didn't need both of those because I know that my slope is negative 4 from the previous problem. So I can do y, I'm going to do HK format. Y equals a, which is my slope, x minus h, which is your x coordinate, plus k, so plus a negative 7, and we are good. You could put that in point slope form. You could have also used the other point, and that would have been y equals negative 4, x minus 5, minus 19. And if you will put both of those in slope-intercept form, you should actually end up with the exact same thing. So, okay, check on example 3. Let's move on to, example 3. Discuss the slope of the secant line if the original line function is linear. So that just comes down to the fact that rate of change is constant. So the slope never changes. Okay, and just remember that's different. Like we showed the parabola earlier, like if you pick this point and this point on your parabola, you get one slope, and if you pick this point and this point, you get another slope. And just for fun, I'm going to pick this point and this point, you get another slope. So a line has a constant rate of change, and the slope is always going to be the same. That actually sounds like a great test question. Wonder. All right. So this says to use a table of values from your calculator to graph the function and sketch the secant line from x equals negative 1 to 3. So I want you just to literally take a moment. I need you to hit pause, grab your graphing calculator, look for a couple of key values. So look at your table of values, plot yourself some points, and graph this function. And then I want you to see if you can find the secant line and then rejoin me. All right. So welcome back. So here's a table of values. So if you want to use those points to sketch your graph, you can. I'm going to go ahead to my next slide. So this is what I got from my graph on Desmos, and you can be using Desmos or you can be using your graphing calculator. Remember, they are both fully functional mathematical tools. If you substituted in negative 1, which actually you could get that value from your table, so f of negative 1 was 6, and f of 3 is negative 26. So if you found your rate of change and you took the change in y over the change in x, you should have gotten negative 8. So now it says write an equation of the secant line. So I don't care, again, which point you pick. I'm going to do HK form again, y equals a, which is my slope, times x minus a negative 1, plus 6. Or if you would have chosen your other point, you have the same slope, but we would have x minus 3 minus 26. Okay, so the big moral of today is connecting all your pieces. So hopefully this is falling into place and you remember slope and you remember all the different notations that we've used and you remember how to use point slope or HK format. All right, well, I hope you have a good afternoon, morning, evening, middle of the day, whatever time it is for you, middle of the night. And I look forward to seeing you tomorrow in class. Have a wonderful day and go do something productive, not your math. Talk to you later. Bye.